All right. Hello, and welcome to America's Next Top Modeler feature. I would like to thank all of you for taking time out of your day to be with me here today while we go over some of the super aspects of SQL Developer Data Modeler. For those of you who don't know me, my name is Dave Schleiss. I've been taking advantage of this computer fad for about 30 years. And for about 20 of those years, I've been working with Oracle products. You can find my social media connections on this slide here. Currently, I'm an analyst with Insum Solutions, America's largest Apex consulting firm, and a really great company to work for, by the way. So we're going to be taking a little journey on the road to what types of scripting are available in Data Modeler and how to use that scripting to help you work more efficiently and produce a high quality, consistent product. Now, Oracle SQL Developer Data Modeler is a really useful tool, especially when you consider the cost. And now many of its features have been well documented in books and blogs and other presentations, but there are, however, some powerful features of this tool that I think are underutilized or certainly under-advertised. And one of these hidden gems is the ability to enhance and customize your models using scripting. Scripting in Data Modeler is available in 3 areas. You can create custom rules to test your models for adherence to a set of design standards that are tailored to meet your needs or that of your customer. Additionally, scripting gives you the power to create and modify your models programmatically, allowing you to perform the same functions that you would using the diagrammer or the dialog boxes. And also, scripting allows you to completely customize the DDL that is generated from your relational models. The documentation provided by Oracle for how to write scripts in SQL Developer can be found in the install directory there's a slightly different path depending on whether you're using the embedded version of Data Modeler or the standalone version. And within this directory, you're going to find 2 files that are really of interest to you. The first is this SQL Developer Data Modeler scripting.doc. And that is an overview of scripting in Data Modeler. And while it's helpful, it's far from comprehensive. And to be perfectly honest, it reads more like a set of notes than actual product documentation. And also there's the index.html file, which is a listing of objects and properties that are available using scripting. Now, if we take a look at this index.html document, we see that it has this alphabetical list of objects in a scrollable section in the left frame. And in addition to the name of each object, you're going to find the fully qualified name, class name, along with hyperlinks to its parent class and also any subclasses that might be children of this particular class. Now, if you're unfamiliar with object-oriented principles, an object of any given class possesses all the properties defined for that particular class, along with all of the properties that it inherits from its parent class. For example, we know that a table is going to have a name property. But as you can see, looking in the properties of the table itself, there is no name property. So what you would do then is look in the parent class to see if the name property is found there. So here we're looking in the parent class, and again, if you look at this alphabetical list of properties, there is no name property. So if it's not in the parent, you check the grandparent, and if it's not in the grandparent, you go up another level. And it turns out that the name property for a table and for all the objects within this model belong to the great-great-great-great-grandparent of the table class, which is the model object. So also within each of these class definitions, you're going to have up to 3 associated information tables that list the properties, some read-only properties, and any associated collections of that object. Within the properties, you will find the name of the property, its data type, default values, and the getters and setter methods. Now, the getter and setter methods, again, this is a standard way in Java programming to assign or retrieve the value of a property. Read-only properties, of course, have only a getter method, since these are more like convenience ways of looking at these properties of the tables, of the objects rather. And also the collections table is going to list the collections that are associated with this class. These are listed separately because there is typically a different way of handling them, and they are more complex than simple scalar properties. So within this collections table, we're going to find the name and the getter property. You're also going to find a way typically to create new items to add to these collections. And also, they're all going to have this get item by ID. Additionally, there are typically ways to add items or remove items from these collections. The problem is that this is really the only documentation of any of these methods that I've found. And while something like get item by ID is pretty obvious that you're going to pass an ID value into this method and you should get returned what you're looking for, how exactly do I use add check constraint? I really don't know. Also, these methods break the convention and don't have trailing parentheses behind them, so it's not absolutely clear that these are method calls and not property names. That aside, if you can't find the answers to what you're looking for in the Oracle documentation, I just want to let you know that please contact me. I'm always willing to help with this scripting stuff. I really like it. And ultimately, the Data Modeler Forum on OTN is the ultimate repository of knowledge of all things data modeler and scripting related. And that's where you're going to find your answers to everything you want to know about scripting, but we're afraid to ask. So with the overview of what's available as far as documentation is concerned, let's dive right in. And the first type of the scripting that we're going to look at is creating custom rules. Now, custom rules are an extension of the design rules available within Data Modeler. Design rules are a means of enforcing, well, more accurately, encouraging a set of rules for things like naming conventions and other aspects of the design of your logical, relational, and physical models. So a data modeler comes with a predefined set of design rules that you can use to check many elements of your models. And by clicking one of these buttons, you can apply a single rule or all of the listed or selected rules against your model. Taking a closer look at these preset rules, you can see that they have pretty descriptive names, and so for the most part, you know what they're checking, but you can't see any of the code behind these rules. And the specifics of what's being tested for many of these rules comes from preference settings. And while that might be fine if you have a single set of standards that your entire company uses, and every project that you have uses, then that's fine. But if you want to be able to switch your rules based on your client or some other setting, some other reason, using application level settings is really not the best way to go about this. And so the preset rules might might just be inadequate. And this is where the custom rules come in. The standard data modeler installation includes 3 custom rules written to test 3 different types of objects. And this will provide JavaScript examples of how to write the rules and to give you an idea of what sort of operations are possible. Taking a closer look at the custom rules, you'll notice that in addition to whether we want to consider this rule an error or a warning, you're going to have to tell which type of object that you're going to be testing. And specifying this target object is important because it helps you categorize your rules, and it also saves you a whole line of code because that object variable does not have to be declared in your script. So this is a complete list of the object types that are available when you're writing rules. You can test your logical objects, logical models, pardon me, relational models, and also process models. So some things to consider when you're creating design rules. Now, the rule name serves as the complete description of the rule, so you should really be as descriptive as necessary. Also, your custom rules are listed along with all of the default rules supplied with Data Modeler. So to easily differentiate between your rules and the default rules, it's nice to add a prefix to the rule name so you can find them easier. All rules must be written to return a value of true and false, responding to pass and fail. And the rule code is automatically run against every object of the specified type. So typically no looping structures are required in the rules that you create, unless you're doing something really fancy. So let's take a closer look at this example rule. So first, in these first lines, it's telling you that the function parameter doesn't need to be named index. So I don't know that it's doing that just to confuse you or why, but we're defining a function here. And within this function, the first thing we're going to do is see if the index is a foreign key. And then if it is a foreign key, we're going to be looking at its foreign key associations and seeing if any of them are not mandatory. And if that is the case, then we're going to look at the columns that make up the index. And for each one of those columns, we're going to loop through that column list and find out if the columns are mandatory. And if any of the columns are mandatory for this non-mandatory foreign key, it's going to return false, which is a fail. And otherwise it would return true. So we've defined the function, and in the end, we call the function for each one of the indexes. So in this case, the variable index has to be used because as you see above, that is the variable that is defined within this script to reference the index. So those listed variables must be used in the testing. That previous example was written in Nashorn JavaScript, and Data Modeler actually allows scripts to be written in any JVM languages. However, only the Nashorn JavaScript is included by default. And while any JVM language can be used for scripting, my recommendation would be to use Groovy. Now, Groovy is a feature-rich, optionally typed dynamic language with features similar to Python and Ruby. And while often referred to as just a scripting language, and it's really good at that, scripting represents only a small fraction of what Groovy can do. I would recommend Groovy because it's got a really concise, easy to use, easy to learn syntax. abundant documentation, and it just makes coding fun again. This is just a little example of how Groovy makes life a little easier. Instead of having to move through a collections using this looping and counting, you can just use the each method to move through a collection. Also, instead of the getters and setters, you can just directly reference properties. It's just very handy. Also, you don't need to use semicolons, and I like that because I forget which language I'm working in, and some of them need them and some don't, and it's just easier not to have to care because you can use them if you want. To get scripting Groovy working within Data Modeler, you would go to the Groovy download page and click the inconspicuous looking download button. You then go to the download location and open the Groovy directory, the embeddable directory within that, and find this groovyall.jar. And then you copy that to one of the SQL Developer Java extension directories. Where do you find that? Well, the Java extension directories can be found by going to Help, About, clicking on the Properties tab, and finding Java extension directories. And there you'll find a colon-separated list of entries for these extension directories. Now, my experimentation has shown that you can put the Groovy jar in any of these directories, but some might be better simply because they might not be accessible due to system limitations. So you restart Data Modeler and it's Groovified. And as an added bonus, this will also allow you to use Groovy in your SQL CL scripts as well. Now, a disadvantage to using Groovy as your scripting language is that you no longer have access to the JavaScript debugger that's built into Data Modeler. And I'm sure it's a wonderful debugger. I wouldn't know, I've never used it. But what this means, since you can't use this fancy debugger, you have to go old school and simply output values as you're running your code. To do this, you can output to the Data Modeler logs. First, by adding these lines to your script. This first line will get a handle to the application object, and the application object has a log method that you simply call. For example, here I am in this rule test, I'm simply looking at the tables and outputting the table name. And you'll see that the output shows up in the log. Just a note, if the log window is not visible, you can make it visible by going through the View menu in Data Modeler. Just in case you write code that might have an error in it, the errors are going to show up in a separate pop-up window. If you're using multiple monitors, it will invariably show up in a monitor where you're not looking. So to write this same rule in Groovy, it would be something like this. First, you click the big green plus sign, meaning you want to create a new rule. You then give it a descriptive name. That's a lot like the other one. You would set the scripting engine to Groovy, tell it that it's going to be a warning, and start coding. So this first part is very much the same because Groovy and JavaScript have very similar syntaxes, and calling these methods is often done exactly the same way. So here again, we're checking to see if it's not a mandatory foreign key association. And this is where things start getting better. For each of the elements in the index, we're going to check them. And if it's mandatory, we're going to return false. Otherwise, we return true. So instead of creating a function and then calling the function, we just dove right in using the already defined index value that's supplied. So we then save this rule, and just as a note, when you click save here, it's not saving just what's shown in your editor, but it is saving the entire list of rules. If we apply this rule, we find that it works. Everything is groovy. See what I did there? So some rules can be very complex, but most of these rules are really quite simple. Here's one that makes sure that the column names, date columns, start with the word date, or making sure that the table names start with a 3-letter prefix. Views have to end with a V. And table names should be uppercase. So these are actual rules that can be run. You can add rules, but of course you can also delete rules. That's what the big red X is for. Again, save saves the entire list and not just what you see in the editor screen. You can export your list of rules. Is exported as an XML file. This makes it easier to share and also to put into version control. Seeing as you can export rules, only makes sense that you can also import this rule, a set of rules. So you click on import, you find your rules, and there they are loaded. And again, you save this list of rules. So this is saving them within the data modeler itself. Now, once you've created some custom rules, you might want to create a custom rule set to apply to your models. Now, this creating of a custom rule set is not specific to scripting. Just want to make that clear. You can create a custom rule set. You can create a rule set using the predefined rules as well as your custom rules. So the first thing you would do to create a rule set is click on the Rule Set tab. Again, the big green plus to create a new one. The little pencil to say that you're going to edit this rule list. And here is where the naming convention of putting a prefix in front of your custom rules comes in handy. You can sort this rule, the rules by the name, and be able to grab only your custom rules if that's what you're interested in. Again, we click the little shuttle arrow and say okay, and we're back to the design rule page where you can save this rule set. Then we're going to apply the rule set, and we see in the right-hand pane any errors or warnings that are caused by the application of these rules against your model. Warnings show up in a blue. The errors are this really dramatic pink color. So if you double click on any one of these, it's going to open up that object in a dialog box. And here we see that I left a space in the name of this column. So if we correct that and save it and rerun the rule engine, you'll notice that now we're only getting warnings. And perhaps for this particular project, we've decided that warnings are fine and we can go ahead and generate the DDL even though there are some warnings. What you might also want to do in this case is save this report as a CSV. This is what saving that the report would look like. Lists the type of problem that was found. Again, under the message, it's the name of the rule. So here we're naming the rule as explicitly as possible. Comes in handy. In this case, you might also, if the project demanded it, you could document on each one of these lines why you thought that it was okay to go ahead with generation, even though these warnings existed. And you could save that in your Subversion directory as well. So custom design rules ensure that your tables are created correctly. And so that everything is fine when you go to generate the DDL. So this brings us to the next type of scripting, which are the table Ddl transformations. And these Ddl transformations give you the ultimate control over the Ddl scripts that are generated by Data Modeler. Just as a reminder, to generate this DDL, you would go to Export DDL file to create the DDL for your entire model. Or if you right-click on a particular table, you can choose DDL Preview to see the script for that particular table. So again, these scripts allow you to run customized DDL generation in addition to or instead of the DDL that's created by designer. Sorry, by Data Modeler. So as with other interfaces, these table Ddl transformation script has the big green plus and red X in the upper left corner. That means you're going to be creating or deleting something. And in this case, what you're creating or deleting are custom DDL script sets. Now, each one of these script sets can contain up to 4 different scripts. The before create script is going to run before the DDL that is generated for each table. So this before create script is going to run for every table. The instead of create would be to change the DDL that Data Modeler is going to be producing by default based on the type of database that you have selected as the target. Now, this instead of create script allows you to change to generate DDL for databases other than Oracle or those that Data Modeler knows about. The after create script is going to run after the DDL for each one of the tables. And the end of script is going to run as a cleanup or a general add-on to the entire DDL script that is generated. Data Modeler comes with 2 custom DDL script set already installed. The empty script is there to give you a small head start in creating your own custom DDL script set. And as the name implies, it doesn't contain any scripts. The journal tables script set contains 1 script, and that's an after create script that adds the DDL to create a standard journal table, as well as the necessary triggers to populate that journal table. So looking at this journal table script, you'll see in the comments that it's going to tell you that all custom DDL scripts have a predefined global object called DDL statement list, and that you have to use this variable to add DDL statements to that which is generated by default, and that your DDL should be in the form of a Java string object. The comments go on to tell us that there are 4 predefined variables available to you when you're creating these scripts. Now, the table variable is going to give you a handle to each table and its properties as you are moving through your model to create the DDL. The table proxy points to the definition of the table in the physical model that the generator is going to be targeting. The model and P model variables provide a higher level of access to the entire relational or physical models. And this allows the retrieval and setting of property settings at a very high level if you would only know what methods to use. See, a while back, I read a comment on the Data Modeler OTN forum, and it said something like, "Again, I am given a fish instead of being shown how." And this individual, of course, was referring to the famous saying of, if you give a mouse a cookie, no, that's not the one. If you give a man a fish, you feed him for a day. If you teach a man to fish, you feed him for a lifetime. So like me, they wanted more than just the answer to their one specific issue. And they were wondering where to find the documentation of the methods that are available for data modeler objects. So this is an example of what Java documentation typically looks like. You see methods with descriptions, how to call them, what gets returned. But in Data Modeler, most of your documentation looks like this. So here we see model, get app view, get settings is included. This is very useful, but without real documentation, we don't know what else is available or what else get app view might be showing us. And while table proxy and table are referenced in the index.html file, and their get name properties are also in that file, get long name is not found in the index.html file. So without this, you would never know that this method exists. Now, I really appreciate the scripting capabilities that Data Modeler provides. And I understand the difficulties in documenting such a powerful tool set. But I really can't understand the reason for not publishing the object methods. Oracle, if you're listening. However, despite the shortcomings of the documentation, the journal table after create script provides us with a solid example of how to write scripts for a custom Ddl script set. I have personally used the journal table script on several occasions, and have also created scripts that added audit column triggers as an after table script. So once you've created and tested your Ddl scripts, in order to include the custom Ddl within the Ddl that is generated by Data Modeler, you first have to set the desired script set as the active script set from this select list. And this is going to apply these custom Ddl scripts to those tables that you have designated as receiving this custom Ddl. So I'm sure you're saying, what? Wait, there's more I have to do? And yes, there is. Under the general properties of the tables, you must select the Use Ddl Transformation Script checkbox for each of the tables that you would like to use the active custom Ddl script set. Is that clear enough? Because maybe you don't want journaling on every single table. So while this might sound like an incredibly tedious task that tools such as this should be relieving you of and not requiring of you, well, you'd be right. But take heart, because this provides the perfect segue into the next topic. So while custom Ddl transformations allow you to do just about anything regarding the creation of your Ddl files, Custom transformations allow you to do just about anything regarding the manipulation and querying of the metadata that defines your models. A common application of transformation settings would be to perform the same operation on multiple objects, such as setting the value of use Ddl Transformation Script checkbox for each of the tables that you would like to use that custom DDL. This sounds simple enough, but where does one start? When you open the Transformation Scripts window, the default installation of Data Modeler includes a dozen examples of rules of scripts to use as instructional inspiration. They're written in JRuby, and the rest are written in Oracle, Nashorn. You'll also notice a message informing you that because JRuby is not installed by default, that some of the scripts have missing scripting engines, and that it also tells you that these scripts are going to be listed in red. Well, they used to be, but the red warning is gone. It's really minor, but kind of annoying since they're telling you it's going to be red. So this has been reported as a bug. So these 12 scripts provide examples on how to access and modify various relational elements within your model. Like the custom rule scripts, you have to select your language and the type of object that you'll be writing the script for. In this case, your object choices are logical model or relational model. The provided scripts are really quite useful, and I began using them well before I knew anything about how this scripting really works. And that was thanks to a post by Jeff Smith regarding exactly what I wanted to do at one time, which was to add standard audit columns to all of the tables within my model. So this introduced me to transformation scripts, and it gave me a hint of the power that they held. You see, long ago, there was this wonderful tool produced by Oracle called Designer 2000. Now, this was before the turn of the century, so the 2000 made it sound ultra modern. And this tool allowed you to define everything about a project in one place. And then you could actually generate the application as Oracle forms and reports from these definitions. But that really wasn't the best part. The very best part was that all of the information that you put into the designer was stored in a repository, a fully documented set of tables and views. This meant that all the information that you went through the effort to put into this wonderful tool was available to you. All you had to do was write a query. So Oracle gave us the keys to the kingdom and a map how to get there. And people were doing all sorts of things with the information in the repository. Back in the olden days, you could count on several presentations at the ODTUG conference detailing new and innovative ways to leverage the data stored in the repository. I myself was among them. My first two presentations dealt with using the designer repository data in different ways. But lo, it did come to pass that Oracle abandoned Designer and sent all of its users into deep despair. In its place, Oracle offered up two alternatives, JDeveloper and SQL Designer. But these tools kept their information locked up in XML files, not easily queryable relational tables. So when I got a glimpse of what was possible with transformation scripts, I saw what I had been missing for so long. I had rediscovered the long-lost data repository. Because not only can transformation scripts be used to modify your models, but they can also be used to extract the information from your designs, which is exactly what we were doing with the designer repository. So Data Modeler is like Designer. Well, kind of. It's true you can't use SQL to extract the information, and the documentation is really kind of weak compared to what was provided with Designer. But all the information you put into the tool is available to use as you wish, and you're limited only by your imagination. I feel like I've rediscovered the keys to the kingdom, and I want to share as much as the map as I have seen. So let's start where I did, and we'll take a look at the provided transformation script for adding the audit columns. So what this script does essentially is look for a special table in your model and add the columns from that table to all the other tables in your model. This script also allows you to, once you have put these audit columns in all the tables in your model, to change the name of those columns. Now, exactly why you would want to do that, I don't know, but the script allows for it. So here we see that the name of this special table is called table template, and this special property that's going to allow us to change the column names is going to be called cTemplate ID. So the first thing we do is we grab the table, the special table, and put that in a variable. And if there is this special table, we continue and get the columns out of that special table. We then go through the model and put all of the tables into a collection, and we then loop through that collection of tables. And here we're saying that if the table that we're currently looking at, if the name of that table isn't the special table, then we're going to do some more stuff. So if this isn't the special table, we're going to grab all the columns from this table. And then we're going to loop through all these columns. And if the columns in the table is not one of the columns in the special table, we're going to create a new column. And so if that column does not exist in the existing tables, we create it and copy the special template column into that table. Now, I understand that this is a lot of talking and hand waving, but this is what is required to do something like this using the tools at hand. The last line here, table set dirty is true. This is kind of like a commit. And as long as I'm saying this, that this is akin to a commit, you have to realize that there is no rollback. So before running any transformation script, always save your design. That's as close to a rollback as you're going to get. Now, we could simply rewrite this rule in Groovy, and I could show you how to do that, and that would be easier to explain. It would save a few lines of code. But ultimately, you still have to remember that to get tables, you need to use table set. It's not just tables. And to get columns, you don't call them columns, you have to call them elements. And that's why I created the SDDM plus scripting library. So you don't have to remember the secret words. It's written in Groovy, and like Groovy itself, it helps you do easy things easily. For example, to get the table, the special table name, there's a method called getTable where name equals. To get the columns, you simply call them columns. Instead of getting all the tables and then stripping out the one that's not the special table, you can simply get the tables where the name is not like something. And if you want to get a column with a particular name, you can also do that. So this is not the same script rewritten, but this is my interpretation of how to add audit columns using SDDM+. So audit columns are first defined using a two-dimensional array. We then look at each of the tables within the model. We take all of the names of the columns from that table and put them into a list. We're then going to look through the audit columns and see if the list of column names from the table contains any of these audit columns. And if it does not contain the audit column, we're going to add that to the table. In my opinion, simpler, more straightforward solution. So, and how we got here was setting the use Ddl Transformation script property on all the tables. This is a script to do just that. I am proud to announce that SDDM Plus is available now on Aura open source. And if we go there, you'll find here it is, and then within the documents, we can look at the methods available currently for SDDM Plus. Now, this log method is what I showed you earlier to send a string to the log of Data Modeler. Show actually pops up a alert box. Ask is a simple dialog box where you are allowed to put in, ask a question and receive one variable back. These are other methods are all pretty self-explanatory. These are general methods for getting tables. There are methods on the table objects themselves, such as get columns and get where name like. Adding and dropping columns is also supported. Now the table.log properties is handy when you're doing more advanced work, in that if you look at the index.html file and the table, you'll see there's a very substantial list of properties. And exactly where the property that you're interested in, the value of the property you're interested in is hiding, can be difficult to find. So by using this log properties method, it will list all of those properties to the Data Modeler log, as well as their values. And not only the properties of the table object itself, but of its parent, its grandparent, etc., all the way up the line. The same thing is available for columns. So these are some really handy features that I wish I had when I started working with this modeling, with this scripting rather. So to use SDDM Plus, you can download it and add the 800 or so lines that are currently in the library to each and every one of the scripts that you're working with here. And as this log message states, that's a lot of baggage to be carrying around. So what I like to do is download the SDDM Plus library, and then you can then parse the local copy into a string variable. Now, this particular window in Data Modeler is definitely not an IDE, and writing code in this window is not at all fun. And like within the rules, clicking save here saves all of the scripts that you have, not just the one that you're looking at. So if you accidentally switch to a different script and touch a variable or delete a letter accidentally and save, those issues will be saved. So the point is that this is not a really great environment to work in. So what I like to do is work in an IDE or a good text editor, create the scripts, and then reference them. And you can do that by simply parsing the file into a string. You can then use the evaluate method to execute the combined script. This is my preferred way of creating scripts in Data Modeler. The next step you can do is to actually, instead of downloading and calling a local reference to the SDDM library, SDDM Plus library, you can actually reference it directly off of GitHub. And while this is a slower option, it also guarantees that you're getting the latest version of the scripts. But otherwise, it works the same way as the method of using a local copy. So how am I taking advantage of the scripting in Data Modeler? Well, back in the designer days, I was generating Visual Basic class objects to help myself and the other developers create applications without having to know the intricacies of the data model. Well, now with my job as an analyst, I use different tools, and they're tools that are designed to communicate requirements rather than build applications. Specifically, I think use things like Jira and Balsamiq mockups. So I've created scripts to help me do that work. So if we have this fairly complex relational model, I run a script, and what it does is it takes the column names and their properties to fill in the UI default values that are available. One of the items, display as, is, so that would say display as text or a select box or whatever. The list that is available within Data Modeler is kind of limited. So I have created a user-defined property called display type. And there I can give it a value of any of the Apex page item types. So I run a script and it fills in these values. I then run another script and it creates a CSV of the tables and all of these display properties. You'll notice that under label, some are hidden. So it uses logic that if the name contains ID, it's hidden. But if the name is a foreign key, if the ID is a foreign key, it then creates a select list out of things like that, as can be seen on this line here. So I can then modify these values that I have in here and run another script, and it injects the modified values back into my design. And based on that, I run another script and I can create Jira cards, a boilerplate Jira card that might not be 100% accurate, but it does give me a great starting point. This also allows me to then run a different script and again create very simple Balsamiq mockups of a form and a report based off of the tables. So again, it's not meant to be a finished product, but it is a good starting point. So that's what I'm doing. And with that, I'd just like to say that Data Modeler is a really powerful tool, and the scripting capabilities make it even more so. So whether you're using JavaScript or Groovy or JRuby for that matter, if you're going to be using this tool, you owe it to yourself to look at the advantages of using scripting. And if you're doing scripting, you should really consider the advantages of using SDDM+. And with that, I would like to again say thank you for your time. This is my contact information. If anybody has any questions, I would take them now. But since this is my very first time using GoToWebinar, I'm not convinced I could. But if you send it something, I'll do my best. Seeing nothing, I would again like to thank you for your time and rapt attention, I'm sure. This is Dave Schleiss signing off, saying happy scripting to all, and to all a good day.